The quantum entanglement enigma. The phenomenon that challenges everything we know about reality. There is a phenomenon in the microscopic world that, for nearly a century, even the greatest scientific minds have failed to fully explain. Something so strange that Einstein himself had to admit, this is spooky action at a distance. That phenomenon is quantum entanglement, a mystery that forces classical physics, modern physics, and even philosophy to step back. Quantum entanglement begins the moment two ultra-tiny particles are born from the same process. From that instant, they no longer behave as two independent objects. They become one single system, even though to the naked eye they appear as 2 points located far apart. The strangeness emerges when we try to measure one of them. The moment one particle changes its state, the other particle instantly changes accordingly. No detectable signal, no delay, no measurable speed because the change happens immediately. This breaks every intuition that traditional science relies on. According to Einstein's theory of relativity, nothing can transmit faster than the speed of light. Yet the synchronized reaction between two entangled particles seems to mock that supposedly inviolable boundary. At first, Einstein insisted that there must be hidden variables information buried deep in the quantum system that we simply had not measured yet. But that argument lasted less than half a century. In 1982, Alan Aspect and his team performed experiments, testing Bell's inequality, and proved that classical hidden variables do not exist. Quantum entanglement is real, not a measurement flaw, not a technological limitation, not a mathematical illusion. Since then, humanity has had to confront an unsettling reality. Two particles can behave as one, even when they are separated across half the Earth. To push this phenomenon to its limits, China launched the Micius satellite in 2016. The satellite sent entangled photons from space to two ground stations, more than 1,000 kilometers apart. The result shocked the world. The entanglement remained intact, as if distance meant nothing at all. This experiment confirmed that quantum entanglement does not weaken with space, does not fade over time, and does not depend on separation. At this point, a profound question arises. If space cannot disrupt entanglement, then does space truly exist the way we think it does? Some theoretical physicists began shifting their approach. Instead of asking, how do two particles communicate? They asked, are they actually communicating at all? Or are they simply reflecting one shared state, existing beyond the categories of position and time? In 2013, Juan Maldacena proposed the ER equals EPR idea. He suggested that two entangled particles might be connected through a microscopic Einstein-Rosen bridge. In other words, quantum entanglement does not occur within three-dimensional space. Instead, entanglement may be the very thing that creates space. If this is true, then position in the universe is not a fundamental layer. Space itself might be a surface created from an invisible web of countless quantum links. This transforms quantum entanglement from a bizarre anomaly into the foundation of reality. Yet the paradox remains. When one entangled particle is measured, the other instantly reacts, but that reaction cannot be used to transmit useful information. The reason is that the measured outcome is entirely random. The two particles know each other, but cannot send each other messages. They synchronize more perfectly than any system humans have ever built, yet they transmit no meaningful information. Some scientists, such as Brian Whitworth, propose that this resembles two variables in a computer program. They do not need to send signals, they simply access the same underlying memory. If reality is informational in nature, quantum entanglement would just be two access points reading from a shared data layer. It is a bold and controversial hypothesis, but an irresistibly compelling one. Many traditional schools of physics reject this, arguing that such views pull physics too close to philosophy and move beyond the limits of experimental science. Yet even they cannot provide a better explanation. Because the deeper we study quantum entanglement, the stranger it becomes. Quantum entanglement is the foundation of technologies shaping a new era. Quantum cryptography that cannot be intercepted, Ultra-precise clocks, based on superposition, quantum computers with speeds far beyond all classical limits, unprecedented high-sensitivity detection systems. But these applications are merely the tip of the iceberg. The submerged part, the place where the real mystery hides, lies in the questions humanity still cannot answer. Why does quantum entanglement exist? Where does it come from? Is the reality we see merely a surface layer of something deeper? Some researchers believe that entanglement reveals the possibility of a secondary layer of reality, a realm where time and space have not yet fully emerged. A beneath-the-surface world, where all systems are interconnected, and where the concept of distance becomes meaningless. In 2022, the Nobel Prize in Physics was awarded to Aspect, Clauser, and Zeilinger, the strongest confirmation that entanglement is not a trick, not an error, not wishful thinking. It is a real feature of our universe. And that truth raises an even bigger question. If, at the smallest scale of the universe, everything is interconnected, then is human separation merely an illusion? Are we living inside an invisible network where every thought, every action, every existence is a single pulse within a far greater system? And if we were to look deeply enough, would we no longer see two particles or two objects, but instead one unified reality unfolding under countless forms? Quantum entanglement is not merely a challenge to physics. It is a doorway to the deepest inquiries about the nature of the universe. And perhaps, when that doorway finally opens fully, humanity will have to rewrite not only physics textbooks, but also our understanding of ourselves. Follow the channel for the next story.